All right, welcome. This is week two of the IM distance learning packet. This is week two, date of April 13th through April 17th. This is page three. The first couple problems is a continuation of page two, so you might want to watch that for a little bit more details on how to set this up. 11, 12, 13, and 14 is continuation of finding the perimeter and area. What I have here is the notes that I used from that was just the formula for the circle. For the square, it was um, uh, a plus a plus a plus a equals to 4a, which is the perimeter. The area was a times a, which is a squared. These time, we're going to work with rectangles, okay? 11 and 12, 13 and 14 are all rectangles, right? So we're going to be using up this formula. There's length and width that we have to define. The perimeter, right, is when we go around, so it's length plus width plus width. Okay, in short, you could write that as 2 of the length plus 2 of the width. Good. The area is length times width. All right. Good. All right. Good. So again, I'm gonna just have the formula here in case if you need it, but we're gonna work through it. First of all, we have to label our length and our width. So let me just color code it for us here. So the length here is gonna be a plus 5, and our width is gonna be in blue, which is gonna be b plus 3. Okay. So our first one is the perimeter, which is gonna be 2l plus 2w. All right. Let's color code that. 2L plus 2 width. All right. Now all we do is make the substitution to 2. L was A plus 5 plus 2, and W is B plus 3. All right. Okay, we should know we should distribute here. So 2 times A is 2A, plus 2 times 5 is 10, plus 2 times B is 2B, 2 times 3 is 6. There are some like terms that we can combine. 10 and 6 do add, so it's 2A plus right here is 2B. 10 plus 6 is 16. So the perimeter here, we would say it's 2A plus 2B plus 16. All right, the area is defined by length times the width. Okay, let's color code that. The area is defined by length times blue is the width. Again, you just have to practice, right? Just repeat. So length is a plus 5, and that's going to be multiplied by the width, which is blue, which is b plus 3. All right, so let's multiply. Okay, we're going to distribute. So the first one's a times b. The second one is going to be a times 3. Let's just move this over a little bit to give us a little bit more room. Then the next one is that's your F first, out, inner, so 5 times B. Then we do our last, which is 5 times 3. All right. A times B is just AB. A times 3 is just 3A. 5 times B is just 5B. 5 times 3 is 15. There's nothing that we can combine here. So our answer would be here as the area would just be AB plus 3A plus 5B plus 15. There's nothing that you can do here. Okay? Let's do 12. All right? Let's just move this over a little bit over so we could have room. Those are just the notes, okay? All right, so again, we have to define our formula as just length is going to be B here, which is, MI stands for meters, I think. And width is going to be A. All right, so let's write down our formula. The perimeter for a rectangle is 2 times the length plus 2 times the width. All right, so make the substitution here. 2L is going to be B plus 2W is A. All right. So 2 times B is 2B. 2 times A is just 2A. So the perimeter here is just 2B plus 2A. They just replaced the, right? We just replaced the letters basically. All right, same thing here for the area. Length, let's color code that for you. Length times the blue is going to be width. All right, so red here was the B times the width was A. So the area is just A times B. Or you could write B times A. Doesn't matter. I just like writing it in ABC order. Okay, there you go. Good? Okay. Let's go down to 13. It's done the same exact way. All right. So first of all, let's find the perimeter. Before we do that, we have to label length is x plus 3. Our width is going to be x minus 2. Let's write down the formula. Perimeter is 2L plus 2W. All right, 2L, 2x plus 3 plus 2, and your width is going to be x minus 2. All right, so let's multiply. 2 times x is 2x, 2 times 3 is 6, okay? Plus 2 times x, 2x, 2 times negative 2 is negative 4. Combine some like terms, 2x and 2x becomes 4x, right? These two combined. Okay, then 6 and negative 4, that becomes plus 2. So the perimeter here is 4x plus 2. All right. The area is defined by the formula length times the width. Okay. The area, all right, is equal to length. Let's plug in the formula. X plus 3. And the width is going to be x minus 2. Okay, and this is going to be multiplying, so we're going to FOIL. Right? So the first one, first, x squared, area. Then first, outer. So x times negative 2 is negative 2x. Inner, 3 times x is 3x. And 3 times negative 2 is negative 6. Okay, area equals to x squared. Negative 2x plus 3x is just 1x. Negative 6 is left alone. All right? So the answer here is x squared plus 1x minus 6. Good? All right. So make sure you understand this. Again, we're just foiling here. All right? Okay. So for 14, it's you would have to do this one for yourself. Look at number 13 for help. All right, so I'm not going to be showing 14, but you can do it by yourself, right? Let's look at 15. It says, if you compare the perimeter between these problems, in what way are the numbers and the units for the perimeters and areas different? Well, what? I don't know what they're trying to get to me. Well, this problem is weird. So this is a very open answer, but in what way are the numbers and the units appear for the perimeters and areas? Oh, okay. So we were supposed to put the units here. Okay. So here, for this one, it was feet and feet. For perimeter, it was just feet, but the area, it becomes feet squared. Here is mi. For perimeter, it's mi squared. All right? Perimeter here is meters. Area is meters squared. Okay, same thing here. Perimeter is going to be inches. The area is going to be inches squared. All right? Okay, so how's the difference? Well, the perimeter can be seen as a 1 degree as degree as having 1 degree of the unit is 1 unit with 1 degree. Okay, is the unit with 1 degree, right? So do you see how here all these are just first degrees, all perimeters are all first degrees. Area um, is different because the unit has um, 2 degree, right? Or this is also called squared. Okay, so the area can be squared as the area can be seen as a higher degree. That makes sense because area is technically a two-dimensional, geometrically two-dimensional, while perimeter or circumference can be seen as one-dimensional. Okay. All right. So the next one, you're going to pull out in all these terms, 16 through 24, you're going to be pulling out the GCF. The GCF stands for the greatest common factor. In the reality, here they just give you it, but in reality, what we're trying to get you to understand is to factor using the greatest common factor. Okay, so let me go over this for you. Okay, so take a look. So let's say you had the number 4x squared and you have the number negative 3x squared. You would have to pull out the GCF, right? So first of all, we're going to find the GCF. What they did is they just write out all the numbers. Factors are referred to numbers that multiply. So 4, what are the numbers that make up 4 that multiplies? 2 times 2. X squared is just x times x. Okay, they just read it out in expanded form. Same thing here, 3x, 3 and x. The GCF is the number that they have in common, so they use this red box to write out x. So right here, you would say the GCF of 4x squared and 3x squared, what the number that they have in common, that's why it's called greatest common factor, see, right? Factors means multiply, greatest means largest. Largest, same number that multiply, GCF. In here, the answer would be x. So in reality, they pull out the x. Okay? So if you think about it, they pull out an x from these two numbers and they fit the numbers in the parentheses. If you would like to check it to get the original, they just factor it. Okay? So think about, remember before we distribute a number in by multiplying, here just think about doing the opposite and just call that factoring by the GCF. Okay? All right. So same idea. Same thing here, but now they have three numbers: 10y cubed, 20y squared, and 5y. So they broke up the number. To, how did they make 10? 2 and 5. How did they make y cubed? Y times y times y. What about 20? 2 times 2 times 5, that makes 20. Y squared, so that's 2y's right here. Lastly, you have 5 and y. 5 and y. The numbers that all these have in common, look, 5, so 5 was in common, and y, y. So what is the GCF here? 5y. So you could pull out the 5y here. What do they have left? 2y squared. Look at what they have left. Look, right here. Look at what they have left. They have a 2, y, and y. That's how they get 2y squared. The second one, 2 times 2 is 4. What do they have left here is a y. And lastly, what number do they have left here? In reality, you can multiply this by 1, right? In this case, it was a, they forgot that negative here. There was a negative out in front. It was a negative here. So that's why they have a negative 1 out in front. If you distribute the 5y together, that's how you can check your work, okay? So here you go. If you want to just take the notes, here you go. Read this if you would like it, okay? All right, so that's what we're going to do here. We're just going to pull out the GCF, all right? Okay, let's do this one, all right? And we're going to write it the same exact way as the example did it, okay? So, one, so let's see how they write it. Do they write out the numbers? Yeah, okay. So they write 15 ABC squared is equal to, what numbers make up 15? 3 times 5, right? Now we do write this. A, then 1B, then C squared, so there's two C's. Okay? Then we write 25, A cubed, BC. 25, we can just break that up to just 5 times 5. There's three A's, so A times A times A, 1B, 1C. Okay, so what numbers do they have this in common? Well, it seems like they have the 5 in common. So 5. Then they have an A in common. They have one O. So I'm just gonna make that in red, okay? Then they have the A in common. So that's A. Then they have a B in common right here. Right? They have a B in common, so that's B. They have one of the C's in common. C. There you go. So this here would be called the GCF. And you're done. Okay? You're basically done. But I'm going to throw this in a little bit. Okay? So we can write here, because you guys are great students, so you're going to do the factoring part. 5 ABC, ABC, then we have a parentheses. What do you have left over on top? We have a 3 and a C. So 3C plus the second term. We have a 5 left and A and A. So it is what? 5A squared. Right? And if you multiply this, if you distribute, you should get the same answer of back there. Good. But here's your GCF. Good. All right. Same thing. We're going to repeat for 17. So 12x5 to the y. Okay. That's going to be equal to, we can do 2 times, what makes that 2 times 2? 2 times 2 is 4 times 3. That makes 6, right? Good. Then we have 5 x's, 2, 3, 4, 5, and 1 y. Okay, next one, 32, x6 and y. So 32, that's 2 times 2, right? That's times 2 times 2 is 4, 8, 16, 32, right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Good. And how many x's do we have? 1, 2, 3, 4, 5, 6, and 1 y. Okay. Let me move this over and give myself a little bit more room. Okay. Yep. There we go. Okay. And good. All right. And 1 y. And now we can see what they have in common. Well, they have a 2. So they have a 2 here. That's 1, 2. Right. Then they have another 2 right here. Good. Nope. Nothing else. Oh, they have one x. Why can't I draw this straight? Wow. Really? Just draw it straight, Mr. S. Times x. Then we have another one here. Times x. Then we have another one here. X. Another one here. Right? These are all what they have in common. Then we have another one here. So they have 1, 2, 3, 4, 5 x's in common. And they have this y and this y and 1 y. Okay. So what's 2 times 2? That's 4. X, 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 x. There's 5x, so x to the 5th power, 1y. And we would call this the GCF. Okay. If you want to factor it, the 4x5y is in front. Okay. Parentheses, what is left on top? The left on top on the first one is 3. Nothing else. Plus what's left on bottom? 2, 2, 2. So 2 times 2 times 2. So 2 times 2 is 4. Times 2 is 8. And a y is on. No, an x is left. There you go. This is how it would look like when it's factored. Okay? All right. This one, you would have to do this yourself. Good? All right. Okay. Let me give you some hints. Okay. Let me move this over. Okay. But you should know how to do this now. Okay. You should be able to do this one. Okay. This is one. So let me help you out by giving you the first factors. Okay. So let's see. 17 PQR. 17 is a prime number, so it's just 17. You have a P, you have a Q, and you have an R. All right. 51 is a prime. uh, PQR to the third, so it's 51 times P, because there's no other factors in 51. P, Q, there's only one Q, and there's three R's. Okay? Oops. You can finish this. Okay? Finish this yourself now. Okay? There you go. All right. Good. Let's look at 19. Okay? This is going to be this is 19 is this is very easily look at mm, numbers 1 and 2 for help. Okay? That's what I'm going to tell you for 19. Okay? I will show you 20 though. 20 I'm going to work out for you because there's three of them. All right? So let's just do it. Let's write it out. So 6x squared. What makes up 6? 2 times 3. How many x's? Two of them. So x times x. What about 18x? Here's 18 and x. What makes up 18? 2 times 2 times what? 9. So 9 is 3 times 3. Okay? So yeah. Right? Because you're breaking it down by factors. So think about the smallest numbers here, okay? You wouldn't write the number 9, right? Because a lot of people would write 9. But 9 can be broken up into 3 times 3. And there's one x there, okay? Then you have the number negative 12, right? So the number 12 can just be what? 2 times 4, right, 2 times 6. But 6 can be broken up into 2 times 3. Okay? All right, so look at what numbers they have in common. You have the 2, you have the 2, you have the 2. So 2. 3, 3, 3. Yep, that looks good. 3, 3, and 3. Do they have x's in common? No. So, right here, you would say 6 would be the GCF. And if you factor it, it would look like something like this. 6 parentheses. I should keep that in red, right? That's the greatest common factor. Parentheses. What's left on top? X times x is x squared. What's left here? 3 times x is 3x. And negative, this is a negative, right? So it's negative 2 is what's left. So that's how it would look like after you factor. All right? Um, again, 21. Very easy. Please look at number 1 and number 2 for help. Okay? Mm, let's see one. Yeah, okay. So I'm gonna make you do 18. I showed off um, a little bit. 19, you're gonna do it by yourself. 21, you're gonna do it by yourself. Let's see. 22. You know what? I'm gonna do 22 for you. I'm gonna do 22 for you. Okay. All right. So let's look at 22 here. Okay. Okay. Then you have an 11x squared, y squared. Okay. 11 is just a prime, so it's just itself 11. How many x's do you have? X times x, there's 2x. How many y do you have? Two of them. So it looks like that. 33 x squared y. What makes up the 33? You have an 11 times 3. How many x's? 2 of them. How many y's? 1 of them. 3xy squared. 3 is the only number there. You have 1x and 2 y's. Okay? So, what do they have in common? You have an 11, 11. Oh, no 11 here. A 3, 3 is 3? No. Uh, that doesn't work. So, what about you have an x, an x, and an x? Perfect. So, that's x. You have a y, you have a y, you have one y here. Perfect. And a y. So, this would be called the GCF. Okay? If you factor it out, it should look something like this. XY, parentheses. What you have left on the top, you have an 11, x and a y. So 11x and y plus 11 times 3, which is 33. 1x plus 3 times y is 3y. There you go. Okay. For this one, for 22, for 23, you are going to look at number 22 for help. Okay, you're gonna um, do this one by yourself. Okay, good. There you go. If you want to check, just factor it out. Okay, good. Good, good, good. I could just show you the answer. So here's the answer in the end, what the GCF looks like, okay? Let's see what the GCF should look. GCF, what should that look like? Four, four, four. I'm trying to do this in my head. B, I know a B would be one of them. 4 times 4, 4, 4, 4, 6. No, yeah, 4, 4B. 4B would be the GCF. Or is it 8? Ooh, it would actually be 8. Because 8 does go into 2. 8 goes into 2. 8 goes into 3. Yeah. So that's the GCF. Show the work right here. Please show the work. Show the work. Okay. For credit. Show the work for credit here, please. Thank you. Alright. Uh, 24. I could do 24 for you. Seems a little bit weird. 49 ST S squared T squared. 49 I think can just be 7 times 7, right? Um, or anything else? 9, 10, 11, 12, 13. No. I think 49. I think those are the only multiples. 7 times 7, yeah. Um, 2 S's and 2 T's. Yep. 36 S squared T squared. 36 is just 6 times 6. Oh, you could break this up though. The first 6 is 2 times 3, and the other one is 2 times 3, right? S times S, T is just T times T. Okay? What do they have in common? Nope. Oh, you have an S and an S, an S and an S, so you have an S times an S. Oh, you have a T here and a T here. So T times T. So the answer here would be S squared, T squared would be considered your greatest common factor. If you would like to see how that looks like when you factor it, ST T squared, parentheses what you have left over, 7 times 7, which is 49, plus 2 times 3 times 2 times 3, which is just 36. Ooh, 49 plus 36, that does become something. Do I have decimals up? Yeah. Okay. Um, what is it? 49 plus 36. Oh, 85. So, you could actually say um, this is S squared T squared, parentheses what? 85. Huh, that's interesting. Yeah, that makes sense. Right? Right? Am I allowed to do that? Yeah, I am allowed to do that, right? Yeah. Sweet. And that's it, right? Yeah, 24. Yep. Good. So again, 23, do it. I gave you the answer. 21, do it yourself. I don't have an answer for you, but you should be able to do it. It's very easy. Same thing with 19. Again, look at these problems for help, okay? Here you go. And let me go back to this page if you would like notes on how to factor in using the GCF, okay? Example A is on top, example B is on bottom. Good? All right. So there you go. Those are all your solutions for page 3.